Good evening, everyone. I'm just gonna give the audience 5 more minutes and then we'll start. Good evening, everyone. We are going to start the session. I'd like to welcome you all to the student information session for the Engineering College of Science and Technology. Just a few housekeeping before we start. If you could just please kindly turn off your notifications, just mute yourself. And then please note that a copy of the slides as well as the recording will be shared with all attendees in about 2 or so days after the session. As previously indicated, this is the student information session. Your future in engineering starts here, so I'd like to welcome you all once again. Today's session, we are going to be going through the purpose of the session, which is to provide prospective students and their sponsors with a clear understanding of Engineering College of Science and Technology and our programs. You're going to be discovering the institution where you learn about our mission, our values, accreditation status, as well as our student-focused learning environment. We will also be exploring the engineering programs that we currently offer, and also the support systems that we have in place for prospective students. Our presenters for today are Ms. Lisa Rootman, our head of college, myself, Busisiwe Mateo, I'm the quality assurance officer. We've got our lecturer, one of our lecturers, Samgelo Nene, as well as another lecturer, as well as the academic head, Eldridge Mapofu. I am now going to be handing over to our head of college. Thank you.
Thank you so much, Busi. Thank you to everybody that's joined us. Good afternoon, and we're happy that you chose to spend this afternoon with us. So, firstly, the Engineering College of Science and Technology is the only private higher education institution in South Africa that focuses on engineering only. So we really have a passion for engineering, and our complete focus is on engineering. So if you are interested in studying engineering, this really is the place for you. I want to talk to you a little bit about what we are committed to do. So at ECST, we really want to support our students to develop. It's important to us that we provide hands-on experience, that we give lifelong learning and also problem-solving abilities to our students, and that our values drive innovation and national growth. So at ECST, who are we? Like I said, Engineering College of Science and Technology. We were accredited, and we provisionally registered with the Department of Higher Education and Training. Accredited by the CHE, the Council on Higher Education, as required for higher education institutions in South Africa. And we also endorsed by EXA, the Engineering Council of South Africa. We are registered on the NQF, and that's the National Qualifications Framework. And we are committed to develop technically skilled and ethical graduates at ECST. So to talk to you about our programs, I'm going to start with the Bachelor of Engineering Technology and Electrical Engineering. This program is registered on NQF Level 7, 425 credits, and it's done over 3 years. Now, most of you would know that engineering qualifications are historically done over 4 years. This really makes our qualification unique, that you are able to complete this in 3 years. Our SAQA ID is 123645. We focus on electrical systems, automation, energy efficiency, sustainable technologies. It's very industry-based, as we discussed in our commitment a little bit earlier. On completion, you can register as a candidate, or on graduation, once you become an alumni, as a professional engineering candidate with EXA, and once you've met the requirements, as a technologist. What is also very unique about our program is our mode of delivery. So we have a blended mode of delivery. Year 1 is face-to-face, year 2 is blended, so it's about 50% online, about 50% on campus. All our workshops, however, take place on campus, and third year is mostly online, with only the workshops being on campus. The reason we are doing this is we really want our students to start integrating into industry during their studies. So the aim is in their third year to already spend a few hours a week in industry. This ensures that our students are more employable and that they are work ready once they graduate. So why should you choose us? Definitely because of us being industry aligned, ECST having such a strong industry focus. Like I just explained, our blended learning methodology, the fact that we're very practical and our hands-on components that are part of our qualifications, the strong student support systems, which I'll touch on shortly, that we have, experienced academic staff, and the fact that we have pathways to employment and further studies. So before I get to the admission requirements, I discussed the electrical engineering program. Also, just to let you know, we have been accredited for mechanical engineering as well. We are currently in the registration process, so we're excited to roll that out in the near future as well. Admission requirements. So you need to have an NQF4 equivalent qualification. So that's either your national senior certificate or equivalent. You need to have English at 50% or higher, basic computer literacy, and then maths need to be 60 and above, and physical science 50 and above. We also have alternative entry pathways for those of you that don't have this specific. For example, if you did N4, N5, N6, so you're welcome to also let us know and we can assist you from there on. Okay, how do you apply? If you haven't visited our website yet, please do visit our website, www.ecst.ac.za. Our website address will also be reflecting on the screen at the end of the presentation. You can apply for our program on this link. You will click on the link. You will be required to complete all your information and also to upload your support documentation. If you meet our requirements, you will then be receiving an email from our admissions department that will let you know that your admission was successful. Ideal student profile. So definitely a technical student, somebody that's motivated and curious, that's committed to learning, and a very strong foundation in maths and physical science is very important, as you just heard in the admission requirements as well. Okay, so our fees and funding options, you can also find this on our website. This is our basic fee structure for the duration of the 3 years. So we have a payment plan. So you can pay in full, after which you can get a 5% discount. You can sign a payment plan where you pay off in debit orders. So we also have student loans. We've partnered with student loans, student hero that our students can apply for. And then we also have bursary opportunities on our website that you can apply for directly on our websites as well. So as I mentioned earlier, student support is a vital component of student studies at ECST. Everything we do is focused or student-centered. Student-focused or student-centered, we really keep the student at the center of everything that we do. So we've got various ways in which we support our students, but the main element is the fact that we've got a learning support officer. And this learning support officer guides our students throughout the 3-year duration of their studies. So what else do we have? We have academic tutoring, we've got a counseling service and many other support services. Then just to quickly show you some of our facilities. So that's our classrooms, our labs or workshops, and also a recreational area. We're very lucky where we're located. It's truly a beautiful office park. Our students have a nice space to relax between classes because they're going to be very focused when they are in class. We even have some ducks on the facilities. I am going to hand over now to my colleague, Mr. Samkelo. Thank you, everyone.
Thank you, Lisa. So I'll just briefly go over our curriculum for electrical engineering. So our first year will be the basics. So when I say the basics, the module that we will cover, we will use what we learned in the first year to apply in the following year, so second and third year. So starting with mathematics. So with mathematics, we'll learn the basics when it comes to calculation and mathematical modeling. And then the second one is circuit theory and analysis, where we also learn the basics when it comes to circuit analysis, and then engineering dynamics and and mechanics as well, where we'll be learning about uh, dynamics and also statistics of the systems, and also do drawing and design, where we also learn basics regarding engineering design and drawing, which will also help us later when we do our final project. And then in industrial experience research projects, that's where we will sort of like learn the soft skills part of engineering. So things like your principles of management, and also when it comes to the workplace. And then the second semester, the first year, we continue with mathematics again. We learn the tools that we'll need to solve problems later. And then engineering programming, we'll be learning about the basics of programming, and also fundamentals of electronics is still the basics. So this is regarding our electronics, whereas with circuit theory and analysis is more like broad uh, electrical systems. And then the second last one is physics and chemistry for engineers, where we'll also be learning principles. Um, so in particular for physics and chemistry, which will also apply in our specialized modules later on. And then the last part is the second part of industrial experience research, which will be a continuation from the first semester. So moving on to the next slide. So this is the second year of the curriculum for electrical. So on the second year, then we will then start with mechanics of machines, so which will be a continuation from engineering dynamics and machines, and then mathematics 3, which will be more in-depth mathematics. So that will be your triple and double integral and differentiation. And then now we're going more into specialized modules, so transformers and switchgear. So obviously now based on what you've been learning on circuit theories, you'll be applying it in particular for transformers and switchgear. Again, even what you learn in machinery as well, and dynamics of machines, you'll be applying in these modules, transformers and switchgear, rotating electrical machines. And then the last module in the first semester, second year, will be then project planning, management and costing, which will be now sort of like a branch out from in natural experience research, where you'll be focusing more now on project planning and also management. And then the second semester, first module, you'll be focusing on so this is sort of like a power or heavy current of electrical, where you will learning about power generation, transmission, and distribution. And then the second part, you will learn about electrical safety, earthing, lighting, and protection. So it's more of like protection of your systems. And then the third part is power electronics and variable speed drives. And then the last part, or the second last, is power quality and energy efficiency. And then the last one is then project planning, which will then be a continuation from the first semester. So as you see, with these modules, now they are more specific regarding subjects, whereas with the first year, they are more broad. So going to the third year, we'll continue from what we learned regarding the heavy current. So now talking about the power system protection. So we have learned about the for example, the module of power generation, transmission, and distribution, where we learn about the whole system. So now we will learn about how to protect the system, and then also its utilization. And then this power generation year, that's where now we'll learn about the 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 the, the sources that we are using now. So in terms of your renewables and so forth. And then we'll also touch on electrical control circuits and also PLC programming. And then the last module, first semester, will then touch on technology, sustainability, and society. So as you see that each year we do have that module that forms part A and part B over 2 semesters where we touch on the soft skills because we also require that as part of our curriculum. And then the final semester, which is second semester, third year, we'll then touch on data communication for power system monitoring. So this is more like advanced system, or rather tools that we use on the systems. And then we'll have our final year projects, which will be our capstone, where we get to apply everything that we've been learning throughout the course. And then again, this technology sustainability and society is part B of what we've studied in the first semester. So that's all regarding the curriculum. So these will be our workshop, which our academic head will quickly go over them. So I want to bring to your attention that we have to do this workshop and pass them to pass the degree, as much as we have done the theory perhaps and passed it. However, we also have to do the hands-on workshop as a requirement to pass the degree. Over to you, Mr. Aldridge. You can take back. Oh, okay. I see you've taken control. It's okay. You can continue.
Okay, thank you very much, Mr. Samkelo, for the wonderful presentation. So yes, as Mr. Samkelo explained earlier, these hands-on practical workshops are such a vital component of our program. So these workshops are actually designed to be incredibly engaging, to ensure that we equip you with the engineering skills that will make you into a technically competent and professionally grounded engineering professional. So let's look at what is involved briefly in some of these hands-on practical workshops that you'll be undergoing. Right, so we have virtual laboratories as well as on-campus physical labs. So a virtual laboratory basically consists of what are called simulations. So you can be able, the key advantage of virtual labs is that you can be able to participate in this from the comfort of your home, or rather remotely via your laptop, via your computer. So you can actually, we have simulated programs that can assist you to actually conduct such laboratory practicals. And on campus, we have several labs that are equipped with the latest modern equipment and machinery that will assist you in grasping the key principles of engineering that you'll be learning in class. So as a critical example, what is shown here is an ohmic measurement setup, so which is basically an experiment to investigate what is called Ohm's law, or in other words, V is equals to IR, right? How voltage, the relationship between voltage and current, right? So as you can see on that setup on the right-hand side, what you can see in white there, that is our resistor. And on the left-hand side, between our black and red terminals, that is a diode. So we are basically just trying to investigate how does the relationship between voltage and current, what does it actually look like through a resistor as well as through a diode, right? So the basic engineering law says that relationship is a straight line on a resistor, and then it is a curve on a diode. So that experiment actually assists us in understanding such relationships. So you will be going through you actually be conducting such experiments. So we have already spoken about that. So that's a non-ohmic measurement, that curved graph that you are going to come out with when you plot your graph of voltage against current. So we also have another key critical example of a Planck's constant set up again to measure basically the photon energy arrays of these different LEDs on different wavelengths. As you can see, they're shown on the right-hand side. Your 430 nanometers, 505 nanometers, all those are actually LEDs of different wavelength. So these will actually be investigated, all of this to try to calculate what is the actual Planck's constant. So this is actually highly informative and quite engaging. So this is a continuation of the previous experiment, now just showing the different infrared LEDs, right? Some of them, they're not visible with the naked eye, so we actually have to use mobile cameras to find out what the forward voltages are. So we also have here pin-tech generators as well as oscilloscopes, again trying to investigate the relationships that are generated basically from different current generators in the form of different waves. Some of them can be square waves, some of them can, they basically have different wavelength and amplitudes. So we pretty much are investigating how the currents that are generated actually operate in, and try to investigate the different engineering relationships. So we also have BXX002C, which is our power and control workshop that will also be undergoing. So this also involves, electronics and wiring. So right here, what is shown here, this is, different soldering equipment, which is quite a key component of electronic engineering and wiring. So this is pretty much how when you, I can basically just give an example. When you open the back of your phone, you unscrew it and then you look at the different components that are inside. So this is actually a result of what electronic engineering and wiring involves. Does it need to be fixed, or does it need to be reinstalled? And end of that, these are the kinds of equipment that are actually utilized in accomplishing such work. So as our student, you will be actually taught on how to operate such equipment. So also with telecommunications, again, you'll also be undergoing different practicals that ensure that your skills are up to date and modern with what the current telecommunication industry requires skills-wise. So these are some of the equipment and tools that you will be taught how to utilize and basically just have a general and excellent knowledge of. So we also have, AC and DC power. This is regarding power generations. Shown here is a direct current generator. So basically investigating the relationships that lead to the generation and distribution of current. How does the electricity in our homes, how is it actually generated? As an electrical engineer, we expect you to grasp such deep and broad knowledge. So these are some experiments that will assist you in understanding and grasping that knowledge. So we also have control circuits, which is your task 4, your H-bridge and PWMs, VFDs or variable frequency drives, Arduino kits as well. So these will also constitute, part of your hands-on workshops. We'll also have another task. Again, this is task 5 on advanced control. So this is going to involve line follower robots, introduction to PLC programming, PLC timers, and traffic light simulation. As some of you might actually be aware, PLCs, or otherwise known as programmable logic controllers, these are actually quite in demand, if I can say, in the current world of the we are actually in the 4th industrial revolution. So, and you have basically heard so much about AI, artificial intelligence, as well as automation. So what a lot of engineering industries are doing, particularly manufacturing industries, is to try to introduce automation, or in other words, how can the work that is being done by human beings, how can we introduce robots so as to increase production, as well as increase efficiency, as well as basically lower any time constraints, as well as costs. So this is where now PLCs come in. So we at ECST believe that imparting PLC skills in you as our electrical engineering student is absolutely vital in ensuring that you become technically competent in this 4IR current world that we are in. So we also have BXX003, which is also electrical and industrial automation engineering workshop, which I have just spoken about in the last slide. So this is now an example of the PLC training kit that you will be utilizing as part of your programmable logic controllers training. So this case is used to practice the programming, operating and commissioning of schematic controllers. Right. So we also have another example here under task 2. This will be activity 1. So what is shown here on the screen, these are water tanks, right? So what we're trying to achieve here is how do we determine or how do we track the level of water in the water tanks using PLC technology. These are some of the skills that will now be utilized. So we need this, be it in our water treatment plants, water supply technology and all of that. This will absolutely be critical. So we also have under task 3 electrical equipment, your alternating current motor control with variable frequency drives, as well as PLC programmable logic controllers. So you will also be expected once again to undergo training involving such equipment. Then we also have power transmission and distribution. So power companies, for example, Eskom right in South Africa, once electricity has now been generated, how is it transmitted and distributed? This is where we taught you as our student how that process actually works. So as a continuation of power transmission and distribution, we also have a generator platform as shown there. So we have a very quite an incredible setup that will assist you. As you can see there on the left hand side, your motor that will actually be utilized in teaching you how electricity is actually transmitted and distributed. So you can see there's a coupling joining the two components right there. So again, that is another critical part of our workshops. So we are striving to ensure that you have all of these critical skills such that when you get to industry, you are not starting from scratch, but rather you have at least quite a decent idea as a very minimum of how these different equipment and machinery actually function. Then we also have, as we spoke about earlier on, our normal laboratories versus our remote labs. So some of you might actually be wondering, what is the difference between a virtual laboratory and a remote laboratory? So earlier on, we said a virtual laboratory actually involves simulations, computer simulations, but a remote lab now. So this is actual physical equipment that you can operate remotely from the comfort of your own home. So right in our labs, we actually have, you will actually be controlling the actual equipment in conducting your experiment, sitting from the comfort of your homes. Whereas with a virtual laboratory, you do not actually use actual physical equipment. You're actually using computer simulations. So that is the key difference. However, both remote labs as well as virtual labs can be utilized from the comfort of your home. So ECST provides you with such a tremendous choice of options that you can utilize, be it physical laboratories, be it virtual labs, be it remote labs. Right, so we can see there an interesting diagram that is showing how you will be interacting with our virtual or remote labs. So on the left-hand side, we can see there is a gentleman that will be you as our student. You are operating, you are on your laptop or on your computer from the comfort of your home. And then with your internet connection, now you are linked to a remote infrastructure now. That is in the case now of a remote laboratory, right? And then that is linked to actual lab equipment. So if it's a virtual lab, then those will be computer simulations now that will be taking place. Right, we see also there is quite an incredible diagram also just illustrating, for example, it monitors the apparatus through the use of video cameras, microphones, and other sensors. So we have various platforms such as Electromeet that we actually use for our virtual laboratories. Right, so PLC does have quite a number of applications. It's also utilized in the programming of traffic lights. So some of you might have wondered when you are driving on a busy highway, you get to a robot and then you wait when the robot is red and then you only go when the robot is green, right? But how do such traffic lights operate? So this is due to PLC programming of traffic lights. This is actually a key area of specialization for engineers. You can actually specialize in traffic engineering and you'll actually be designing traffic lights and their functioning. And so this is a continuation again from the last slides of how PLC programming is vital in the management of traffic lights. We thank you so much for your attention. I now hand over to my colleague, Ms. Posisio. Thank you.
Thank you very much, Eldridge. As you guys can see, we've got very informed lecturers, so this is the type of content you'll be getting if you do decide to join us here at ECST. Now, we've covered the entry requirements, we've covered the different prospective workshops, and now we can now address the career pathways and industry relevance. So graduates will have diverse employment opportunities when they do our program, which is really a vital or really the core essence of why you're studying. You want to have a career. So as Lisa has already explained, once you completed our program, you can then register as a professional engineering technologist or a candidate at first. And once you meet all the requirements for EXA, you will then be a professional engineering technologist. So these are just some of the career pathways that students can pursue once they've completed our programs. I'm not going to read all of them, but just some are electrical system planning, design and development. We've got the renewable energy, electronic research, design and testing. So there's quite a few things that you can pursue a post completion of the qualification. Another thing also is pathways. I'm not sure if we mentioned it, but the benefit also with studying with us is that you've got a possible pathway to UK and Australian master's qualifications. So that is going to be all from us. Are there any questions?
Lucy, I think while we wait for questions, just thank you so much to all my colleagues. This was very informative. Just to answer a few questions that's usually asked if anybody wanted to know. So we are based in Midrand in Waterfall Office Park. It's quite centrally located. There's lots of amenities around us. We've got the Gautrain close to us. We've got Mall of Africa. Other public transport. We also have parking for students with their own vehicles. So we really are in a good location. We also have student accommodation close to us. Student accommodation also have transport to and from campus with facilities that has Wi-Fi, etc. So that's also quite convenient for students that don't reside in Gauteng or that it's too far to travel, even if you are in Gauteng. Um, Please also check our website. All our open days and events are listed there. We host webinars every second week on very interesting topics. Please do join us for these webinars to get more information. You're welcome to email us, give us a call, just pop up at our campus if you want to meet us and find out more about us. We really would like to meet you and share more about ECST with you. We're also currently running a special for our July intake. There is an early bird discount of 10%. So if you'd like to enroll still within this month, you can do so and get a 10% discount. So please do feel free to do so. Thank you, Busi.
Thanks, Lisa. Do you want to touch on the winter school that's coming up?
That's a great idea. Yes, we do have a boot camp coming up for our matriculants, and we would like to invite our matriculants to register for it. It's also on our website. It is happening the week from 13 to 16 July on campus. If I'm not mistaken, the 13th and the 14th is maths, and the 15th and 16th is physical science. This will be to prepare students for the matric exams, and it will give you guidelines on how to prepare for the exam, but mostly focus on the problem areas to prepare for matric exams. That's one of the things we also ask on the registration form is what area do you most need assistance with? So please do register and come and join us for the boot camp. Thanks, Busi.
Thank you, Lisa. Are there any other questions? While we wait, I've just displayed the contact and information resources. This is where you can get in touch with us. We've got our website there, our email address, as well as our telephone number. You can call us anytime. There's always someone that will answer. You're also welcome to do walk-ins, and we'll have our program advisor take you around and show you the campus. As Lisa has already indicated, we are in Midrand. We are in Unit 3 Elevation Gardens. We're in Waterfall Office Park, so please feel free to just to join us anytime and come view our campus. I am not seeing any questions, so I think we are going to close. Do any of the presenters want to say or add anything?
Thank you, Busi. Once again, we encourage you to visit our campus, as stated on your screen. You can see right there. We encourage you to come see our world-class modern facilities as well as laboratories. Thank you.
Thank you very much, everyone, and thank you once again for joining this information session. Just a reminder that this presentation will be uploaded on YouTube. We'll also be sharing it with all attendees. So thank you once again for joining. Good
Thank
night.
you so much. Bye-bye.
Thank you. Bye-bye.
Thank you. Bye.